Everyone, and welcome to our first session of the day on the LLM track. Thank you all for coming to PyData Global, and I hope you've had a great day thus far. I'd like to introduce our first speaker, Sara Zanzottera, who's going to be talking about building LLM voice bots with open source tools. And without further ado, I will hand over to Sara.
Thank you. Thank you very much. So let's see when my screen comes up. Here we go. Okay, perfect. So thank you for the introduction, and indeed welcome to everybody. Today we're going to talk about indeed building LLM voice bots with open source tools as much as possible. So let's jump right in and see what this talk would be about. First, just to introduce the topic, what is a voice bot? I guess everybody knows here in the audience, but we define normally a voice bot as any software that can interact with users using voice in a way that feels like a natural conversation. So for a long time before LLMs came about, then this was a very hard task, and in general, very few things could qualify as real voice bots like Alexa or Siri. But after LLM appears, and especially the latest GPT developments, a lot of people believe that like building voice bots is a sort of solve problems. LLMs can do exactly this, right? So they are designed to talk, they're designed to have conversations. So building voice bots like this should be much simpler. However, specifically when you're using voice, so audio conversations, there are many challenges that people normally doesn't think about when they are developing a project like this. First of all, let's see a few of these unique challenges that you might be facing. The first of all, and the one that mostly people actually remembers about, is latency. When you're talking to a person, their reply must be coming pretty fast. And the LLMs tend not to be very quick at generating their responses. In practice, for example, when you're having a phone conversation, replies normally should arrive between 300 milliseconds or 500 milliseconds. That's when it feels the most natural. People normally can wait up to 1-2 seconds for a reply to like their questions or their sentences, but above that it really starts to sound very strange, and people might actually not manage to have a conversation with your bot if it's too slow to reply. So latency is a pretty critical part of a system like this. But also there are features of the conversation itself. For example, interruptions mid-sentence. When people is talking, it's very often, very frequently, they may talk over each other for very little periods. They may interrupt each other, they may jump in, they may say something else. And also, LLMs especially are not very good at this. Actually, many LLMs cannot do this at all because they expect your message and then they will generate their message and then you will send another message. So they are really turn-based, while real conversations are not turn-based at all. Similar to interruptions, but exactly the opposite, actually in practice, is what is called back-channeling. If a person is explaining something to another, sometimes the person listening will keep like saying little words like, okay, yeah, sure, keep going. And these little sentences are not supposed to interrupt the speaker. They're actually supposed to just give feedback. And if an LLM is designed to handle interruptions, so it's already like one step ahead, it has to also make sure the back channeling doesn't break the flow. So when a person says, yeah, sure, they should not stop and react to that because that's not what the other person intended. Other details about how voice can be hard for machines is, for example, things like foreign accents. Normally, LLMs and any other system that handles with voice is designed to work with mostly native accents, or at least is trained to recognize and deal with native accents. And foreign accents often like just throw it off or make it very difficult for the machine to understand what's happening. But also like phrasing itself. People, when they talk, they often don't just like say a full well-formed sentence from the start to the end. They add padding, they hesitate, they have pauses, they repeat themselves. It happens, but that makes it harder for the machine to like follow the sentence. It's not like text, it's very differently structured. So also this can pose a challenge to an LLM that is mostly designed to handle text. There are other techniques that call them techniques, like some things that have happened during the conversation. For example, over the phone, if there is a lot of delay or the other person stays silent for a long time, users may be pinging it. They may be asking, "Are you still there?" And if the bot was just being slow at replying and it was actually processing the request, and the user says something like this will just delay again the next reply because the bot will receive another message and will restart again from scratch processing that. And it will just delay the conversation over and over, or make the bot and the person talk over each other every time after a pause, like when they are really desynchronized. One other thing is, for example, buying time. If the user is doing something, or the bot also is doing something that will require a pause to happen, and they say, okay, wait a second, the other party should understand that, okay, silence is expected, so I'm not supposed to be pinging it, or I should not be saying anything, or at least like that the silence is expected. Bots, especially like LLMs, don't really have a sense of time. So even if the user says, wait a second, the LLM will probably just not get it and will just handle the silence as if it was unexpected, even though the user clearly had a disclaimer about it. So there are a lot of unique challenges regarding really voice that you have to pay attention to while you're developing a bot like this. So what's the state of the art, more or less? There are right now two main ways to develop voice bots. One is to have an audio to text pipeline, which is composed by many components. And then more recently, there is also a new option that is what is called an audio to audio, which is much simpler, but at the same time more difficult to use in practice. So we will see both of this immediately. First of all, let's see the audio to text. The audio to text version of a voice bot is the more like established one right now. So it has been around since text LLMs has been around actually since much earlier, but in this current form that I'm gonna explain is mostly was around since LLMs existed. So it is made of 4 parts, and you can see each of them what they do. The first step when the user says something is that its audio is sent to what is called a voice activity detector. The full stream of audio, regardless whether the user is actually speaking or not, is sent to this model that is normally going to be able to tell when the user starts and stops speaking to inform the rest of the pipeline of what's happening. There are a few options in this space, for example, Celero's models or Pico voices, which are mostly open source as much as it gets for at least this sort of machine learning models. So they are open source, they are self-hostable most of the time. So they are pretty good, and they tend to be the fastest part of this pipeline because they really work on real time. They are relatively smaller models. So this is rarely the component that adds latency to your system. Once the voice activity detector has identified the piece of the audio that contains actual speech, that part only is moved to the speech-to-text engine, which there are also a few options out there for it. One of the most famous one and the best one in terms of open source, it's Whisper, considering both quality and like openness, let's say. But there are also several closed source proprietary options here. For example, DeepGram, which tends to be a little bit better, but still Whisper is very, very competitive with it. So speech to text has also decent option in the open source space. So after the speech to text has converted the speech into text, the text is ready to be fed to an LLM. And in the sense of text-to-text LLMs, we have really a lot of options. You probably know there are like proprietary models like OpenAI's and Anthropic models, but there are also a lot of open source, more or less open source version of these LLMs like Llamas or more recently Qwen models. So also a lot of options in terms of text-to-text LLMs, just because text-to-text is the most common modality for LLMs to work right now. Once the LLM has generated a reply, this reply will go to a text-to-speech engine, which does the opposite exactly, so takes the text and generates speech out of it. In this area, text-to-speech has been around for a long time, so there are many open source options, but the ones that are really the best tend to be proprietary still, like the ones that give the more inflections to the voice, or they have more options for voice, more languages supported. Unfortunately, they tend to be proprietary right now. So, for example, Cartesia or 11 Labs tend to have the highest quality. OpenAI and Azure have also like many other options. So you will have to like figure out how much you can like which sort of models do you want to use if you can use a proprietary one that has higher quality, or if you prefer to go open source all the way. Okay, so what are the pros and cons of this system? So one of the main advantages here is that you are actually at the end handling text. So the LLM will be handling text, and this means that you have a lot of options available, more or less smart, more or less fine-tunable. Using a text-to-text LLM is pretty nice because you can fine-tune it. It's very easy to fine-tune. There are many options, etc. And also, to be honest, most of the layers have decent open source options. So you can build this whole stack just with open source models. It is also fast enough for products. This is a common misconception that these pipelines tend to be very slow, and indeed you will see a lot of, for example, demos that are really slow at replying, because achieving like a good latency is not trivial, but it's totally possible. So you can build a good audio to text pipeline that replies actually on time. And there are also open source libraries that build the whole stack for you. So you don't have to like go and build the entire pipeline yourself, selecting all the components, etc. There are like libraries that do sort of like end-to-end audio to text voice bots. For example, PyData or LiveKit agents. I will have actually a demo which I cannot present today due to time constraints, but if you're interested, I will share the link later of an agent like this that uses PyData. So just in case you're interested, ask it in the questions later. The disadvantages is that the audio to text pipeline have an inherent limitation on how much of the audio can understand. They cannot really understand anything in the audio that is not transcribable to text. So any audio clues they can get, the tone, the pitch, the emphasis, it's all lost. And there is fundamentally no way to recover this sort of information. The opposite is also true. So they cannot generate anything other than voice. They cannot generate any other sound, nothing. So also inflection sometimes is hard to achieve with a text-to-speech model. So this is something that is an inherent limitation of a pipeline like this, and it's very hard to do something about it. There is also a bit nuance of the phrasing itself, because these LLMs generally will generate text like they expect it to be writing, and we normally don't speak as we are writing. So when an LLM replies, the conversation will always feel a little bit rehearsed, like prepared, simply because there will be no padding, no hesitation, nothing. So it will feel a bit stiff. Still pretty natural, but not 100%. And again, there is the issue with like low and stable latency that is not too simple to achieve, because simply you have a lot of components in a pipeline like this. The alternative is to have an audio-to-audio system, which it's basically not a pipeline even, because you simply send the whole stream of audio to an LLM, which is able to understand such stream, and the LLM will send you back an audio stream that is generated directly. Honestly, there are not that many options of models out there that do this. The most famous one, and honestly, one of the few that you can actually use for a product, in my opinion, is GPT-4o Real-Time, which we all know has its own problems that we will see in a second. There are open source options. For example, there is a Llama Omni that can also do this, or a Moshi from QUTI, which also can do exactly this. So take the full audio and produce full audio. But if you try actually to use them, you will see that there is a steep quality difference between the two, within the GPT-4o options right now and the open source ones. So we might need to wait for further developments, both for the proprietary and the open source models, to actually have something that is comparable to the old audio to text stack. Again, just to have a very quick overview of the pros and cons. The advantages of an audio-to-audio LLM is that the response time is fast and stable, because simply there are less components in this pipeline entirely. They can at least in theory, understand these audio clues. So, for example, in the tone or pitch or something like this. And they can also understand any other sound that might be coming through the pipeline, in theory, because in practice, these models tend to be much, much better at understanding voice. And they kind of try, at least right now, to understand other sounds, but they're not very effective with those. They can also generate other sounds because indeed they're just generating an audio stream. So they have, in theory, the possibility to do so. And also their conversational style is much indeed more fluid. It feels less like they are just reading a script. The disadvantages, however, are many because, as I mentioned, there are very few options available and they tend to be really, really expensive. For example, GPT-4o real-time right now, it's like basically costs, I don't remember exactly the multiplier, but it was, I think, 5 times more than running a GPT-4o plus all the other components. So even if you have the most expensive ones, the most expensive options on an audio to text pipeline, and you compare it with the pricing of a GPT-4o real-time, GPT-4o real-time is still more expensive and by a lot. So yeah, you need a really good motivation to be using that one right now for a production system, simply because of the cost. They also, when you use them, tend to be a little bit less smart than text models, even the best ones. You can feel a little bit of a difference between the way they reason, the way they speak, or the way they simply are able to follow instructions. So probably due to the fact that they were trained on audio, it somehow has a little bit of an impact here. Probably it's just harder to train them. And also, as I mentioned, the open source options are really not very good, not really there yet, I would say. Okay, so let's have a talk. Let's have a word about conversation design, because so far we have been talking about how to actually make them speak, but LLMs are not simply like just ready to go out of the box. You have to tell them how to say what you mean them to say. So, for example, if you're building a customer support bot, you need them to be able to like handle customers. Or if you're building a game NPC, you want them to do what the game expects them to. So it's not just an LLM just plugged in. You need to design the conversation. And let's see, how do you do conversation design with LLMs, right? In case you didn't know, LLMs have what is called a system prompt. A system prompt is a special prompt that goes at the start of the conversation, both for like voice and text LLMs. By the way, this is the same for both kind of models. And it contains a few instructions that the model has to follow throughout the conversation. For example, it describes its personality, or it says what it should and shouldn't do. As you can see in the little example on the side, it can be very simple. For example, some prompts can be, you are like Jane, a helpful assistant, and sometimes that's enough for a use case. But sometimes you want to really put in a procedure, or like a checklist of things that the bot should do, and all of this stuff go in the system prompt. This is set by the application developer, so users will never see it unless they really try to do prompt hacking. And also, one thing that many people do not realize often is that the LLMs are stateless. So every time they generate the next reply for the user, they have to read the full conversation from the start. So it's not like they have an internal state of the conversation. They will read it every time. And so as the conversation grows longer, also the cost of the request in terms of time and in terms of like processing power will grow, simply because the conversation is made of more tokens. This also has an advantage, though, that you are free to change the history as you like. If you want to change the system prompt mid-conversation for any reason, you want to make your character change personality, for example, you can do it by just rewriting the system prompt and changing it completely. And the LLM will rather follow the one that is in the history that you provided them, because it has no state, it has no knowledge of what happened earlier. So that's what will happen there. Again, the problem with system prompts is that they are often bottlenecks. When, for example, you have a customer support bot, it often happens that the procedure you have to add to the system prompt grow and grow and grow until the system prompt is so long that it becomes slightly contradictory. It becomes like so long that the LLM just cannot find its way through it. And then the rate of hallucinations grows because the LLM struggles to follow all these immense amount of instructions. This is true for even the most cutting-edge models like GPT-4o, for example. The fact is that conversation design is not a new problem at all. So even like intent-based bots, the one like that pre-LLM era, they were also like having the same problem, and they solved it by using a sort of like conversation tree. You divide the conversation into tasks, and then you let your system tell you when they believe the subtask is done and then to move over. So instead of having a system prompt that contains all the information for all the possible cases that the bot has to handle, you might rather give it just subtasks. For example, tell me what the user wants support with. And then once you understood that, you will actually give the bot the procedure for only that task. Let's see briefly an example about this. So how do you implement this? There are two stages, in fact, to this process. First of all, the LLM has to understand what the user is trying to do. So the first system prompt will not be about like you are a customer assistant agent. It will be rather read this conversation and tell me what the user is trying to do. In this case, for example, the user is saying, I want to use a promo code to upgrade my subscription, let's say. And the assistant will reply not like, okay, how can I help you? But he will say 3, because 3 is what is the number of the intent that the user is trying to accomplish. In this case, apply for a subscription. Once the LLM replies with the number of the intent, we, in the rest of the system, we can go into our library of prompt, figure out what system prompt matches the intent that was described, and basically replace it at the start of the conversation. And the final conversation will look something like this. Instead of you are just a customer support agent, you're like your customer support agent, and you are helping a user apply for a subscription. So we're already like putting the LLM on rails. You're doing this and this only. So follow this specific procedure, and the LLM will know nothing else and nothing about any other of the procedures that it might be needing to handle. Of course, when the user is done, then the LLM will be asked again to like check if the user wants to do any of the other intent, and the loop will go on again and again. Just basically dividing the whole system prompt into subtasks and letting the LLM handle it this way. All right, so we are in time for a small demo. Let's jump right in and see what we're gonna do. So I implemented, in this case, for simplicity, with GPT-4o real-time, so with the audio-to-audio LLM, a little in quotes, little bot that can handle something like a half of a realistic customer support bot, right? So in this case, I listed 13, 14 use cases, the one that I could come up with. And in the demo, we're going to trigger just one of these, the subscription upgrade. So I'm going to tell the bot that, I want to upgrade my subscription, just generic question. And the bot will actually help me through, because this is a bit how the flow will go. Again, very, very simple, just for the sake of the presentation. In here, we see that the bot will first ask me for the customer ID, and then it will ask me for my promo code, and then it will try to do the upgrade by calling a tool. And if the tool succeeds, it's going to tell me, okay, that's all good, and close the conversation. Otherwise, it will tell me, okay, the upgrade didn't work, so we're going to be in touch with you. Something like this. Very, very basic. In the video, you will see a UI like this. On one side, you will see there is the chat history, which is also using transcriptions that the model is providing us just for convenience to know what's going on. At the bottom, there is going to be the state of whether the user is speaking or not, or silent. And on the other side, there is a system prompt that is active right now. In this case, you will see changing as the conversation goes on, because the system in the background is basically first querying the LLM for the intent, then getting back the reply, and then updating the system prompt and querying it again. So consider, even for latency purposes, that all of this is making 2 queries to the LLM, and yet the conversation is fluent enough that it doesn't feel like you have to wait on the phone for the reply. Okay, so let's move to the recording. Let's see if everything works. If you want to try to run the demo yourself and you have an OpenAI key, you can also find the instruction on the link there. We will share the slides later, so don't worry about copying the link right now. Okay, so the demo is here, and I should be able to run it from the start. Okay. All right, so this was it. Again, I like a very, very simple demo, very, very simple workflow. But you can see that something like this scales pretty nicely because each of the small prompts is just given for each of the procedures. So if the user later would say, okay, I also need help with that, the LLM will restart again the loop and ask and support the user for another task. So yeah, this is a bit how it can work. Again, this was done with an audio to audio LLM, but if you're interested, I have a similar demo for an audio to text one, which would require too much explanation also to be made justice of. So in case I can share the call up later. And you can also run this one yourself on your machine. Yes, this demo was made with a library called Intentional that I developed myself. Is in very, very early stages, so don't expect anything to run out of the box. But if you want to contribute, if you want to leave some feedback, just go to the GitHub repo or check out the documentation. Just get involved because it's starting right now and it's designed to implement exactly this approach. Okay, so that's it. I will take some questions now. Let's see, I should still have a few minutes. And that's all. Thank you for listening. All right, let me see. I don't see questions yet, so I'm assuming there aren't. Okay. Oh, interesting. Okay, so this question says, the control tree structure, is that also a prompt to the LLM or a hard-coded? No, so the tree structure there is something that you build outside of the LLM. So you will have a script outside that basically takes the LLM response, processes it, and then send another query to the LLM. So in fact, the LLM is receiving 2 queries each time the user says something. First of all, what is the intent? And then it will also generate a response considering this system prompt. So no, the tree structure is outside of the LLM right now. Okay. Yeah. Interestingly, while we wait for other questions to come, if they have, I think I can show you. Yes, this is the other demo I was mentioning. Again, takes too much time. So in case you are interested, just check this out too. Okay, next question. So from your experience, how do you text this fast enough? Any experience with other languages than EN? With English, sorry. Main languages, let's say popular languages, Spanish, Italian in my case, or popular languages tend to not have any problems. Lower frequency languages indeed are a bit of a hit and miss. For example, I've had the possibility to test with Hungarian, and that it really depends by the LLM. like top of the line LLMs, GPTs, or also llamas, to be honest, don't really have problems. Not anymore. It used to be a problem at the start, but right now not anymore. But other LLMs you really have to test. If you don't expect to be using them with just major word languages, you might want to do that. And also, the system prompts normally work in English, so you don't need to have the system prompts in the target language if you're handling multilingual scenarios. But you might have to really stress to the LLM that, yeah, you have to reply in that language, because otherwise it can switch back. That can happen indeed. Not too frequently, it's getting much better with time, but it's still a little bit there. Next question. How's it affected? Oh, yes. So how being a polyglot has affected your view towards these technologies? Or did the tech make you want to learn more languages? Chicken and egg? Oh, I mean, that hits home very much, because as soon as LLM came out, indeed, like one of my first applications was like, okay, I can use them to teach languages. And indeed, I think that there is a lot of potential in there. I also expect LLMs to like really help with how can I say, translation and localization of content. So I expect also the internet to become a little bit easier on non-English speakers, so that learning languages will be a bit less needed, because the LLMs can do more translation and more effectively. But again, LLMs for translation and for language learning, I think that's a huge topic in itself, and like something I'm quite interested about, by the way. So if you're also in the area, just also you can write me. We can have a whole discussion about this. Okay. Last question is to come, or is or this was the last question? Just making sure.
Yeah, that's all the time we have.
Okay.
Thank you, Sara, for that fantastic presentation. I really enjoyed that.
Thank you.
Thank you, everyone, for coming. The next session on this track will be at 4:30, Enhancing Maternal Healthcare, Training Language Models to Identify Urgent Messages in Real Time, with Zanzottera. I'd like to say, well, one more massive thank you to Sara for that awesome presentation, and I hope everyone else enjoys the rest of their conference.
Thank you, everybody. Bye-bye.